Hi everyone, so in this video I'm going to be talking about algorithms, to be specific, it will be sorting algorithms, and in this playlist I'll be doing all the sorting algorithms like bubble sort, selection sort, insertion sort, merge sort, and also the other sorting algorithms like shell sort, bucket sort, like advanced sorting algorithms. And also we'll be doing questions in this algorithms. Okay, and in my upcoming courses, which I'll be doing in a parallel way, we'll do the Java course and also the interview questions of like Facebook, Amazon, and those kind of companies. Okay, so so in this video we'll be seeing bubble short and it's like how it works, how is the code of it, and lots of other things. So let's get started. So first of all, we have to talk about what is bubble short, right? So bubble short. So bubble short. So what is bubble short? Basically, what is a shorting algorithm? Shorting algorithm is arranging a list in a ascending or a descending order, right? You already know, of course, what is ascending or descending order means. So what happens in the bubble short? Suppose you have a list. Suppose you have a list. Suppose the list is 3, 4, 2, 5, and 1. Suppose this is a random list. Okay. So this is the list. Basically, first of all, this is not sorted. Not sorted. Okay. So in this list, what we'll do, in case of the bubble sort, we'll take the two adjacent elements. This is the adjacent elements, right? This is the adjacent element for this. This is the adjacent element for this. These are two adjacent elements. We'll take two adjacent elements at a time. What we'll do generally, let's reduce this. Okay. So what we'll do, let's in the first step, in the step one, we'll we'll check the first adjacent elements. Suppose we're checking this. So what we are checking? We are checking. We are checking if if the left hand side is smaller than right hand side. If it does, then it is okay. It is right. It's correct. But if it does not, else what we'll do? We'll swap. We'll swap the two basically items. You can say two elements. We'll swap the two elements. Right. So we'll swap the two elements. So in 3 and 4, we have 3 and 4. So 3 and 4 is the 3 is less than 4. So it is correct. So what will be here? It will be step one. It will be first of all it will be 3, 4, 2, 5, and 1. Then we'll take the second additional elements. This one. So is it correct? Is 4 is less than 2? No, it's not correct. So what it became? It will became 3, 2, 4 after swap. So we'll swap these two elements, right? We'll swap these two elements. Now the second pairs are the second pairs are this, right? Is it correct? Yeah, this is correct. So what it became now? 3, 2, 4, 5, and 1. And again we check this pairs. So is it correct? No, it's not correct. So what it became? It became 3, 2, 4, 1, and 5. 3, 2, 4, and 5. So this is the first step. This is step one, which is to done the step one. Now we go to the step 2, 3, 2, 4, 1, 5. Okay, 3, 2, 4, 1, 5. So next we're going to the step 2, and it is 3, 2, 4, 1, and 5, right? So when is the 3, 2, 4, 1, 5? So again we are starting with the first adjacent elements, first two adjacent elements. So now what we'll do, we'll do 3, 2. So we'll take 3, 2. Is it correct? No, it is not correct, right? Now it's not correct. 3 is not less than 2. So it's not correct. So it will swap the two elements. So it will become 2, 3, 4, 1, and 5. Again, it will take these two elements. Is it correct? Yeah, this is correct. So it will become 2, 3, 4, 1, and 5 into these two elements. Is it correct? No, it is not correct. So it will become 2, 3, 1, 4, and 5. Now I'll check this two elements. Is it correct? I will say yeah, it is correct. So it will get 2 3 1 4 and 5. So step 2 also completed. Step 2 also completed. So now we'll go to step 3 actually. We'll go to the step 3. Step 3. So step 3, what will be in step 3? It is 2 3 1 4 5. It is 2 3 2 3 1 4 and 5. So 2 3 1 4 5, and this one is this two additional elements are in correct order, means 2 is less than 3. Yes, 2 is less than 3. So I will get 2 3 1 4 and 5. Is 2 elements are correct? No. So we'll get 2 1 3 4 and 5. Then we'll check if 3 and 4 are in the correct order. Yep, this is in the correct order. So now it will be 2 1 3 4 and 5. And now again we'll check if this one is in the correct order. No, this is not in the correct. Okay, this is in the correct order. Yep, this is in the correct order. So basically what I'll do, we'll check. Okay, this is equal, so it will become 2 1 3 4 and 5. So this is the whole explanation of the bubble shot algorithm. So the okay, no, this is not it's not really shorted actually. We'll go to the step 4 actually now. We'll go to step 4. We'll go to step 4. It will be 2 1 3 4 and 5. So we'll check the first two elements. Is it shorted? No, it is not shorted. Basically, it is not in the correct order. So it will be 1 2 3 4 and 5. Okay, so yeah, 3 4 and 5. 1 2 3 4. Just give a minute. Just give me a buck. Okay, 1 2 3.5. So now it is in shorter order, but it will continue to check because there is no stopping condition. We didn't give any stopping condition, so it will continue to check. Is the correct order? Yep, it is in the correct order. So it will give you 1 2 3 4 and 5. Now this is, if this is in the correct order. Yep, this is in the correct order. So it will check 1 2 3 4 and 5. Okay, 3 4 and 5. So let's get good. 3 4 and 5. And then again I will check if this is in the correct order. I'll check, yeah, this is in the correct order, so it'll just give me, it was 1 2 3 4 and 5. So this is now, shorted. This is now shorted. It's now shorted. So this is the whole explanation of bubble short. How bubble short works. The bubble short generally takes two additional elements and check whether it is in the correct like order or not. If it's not in the correct order, it will swipe it. If it's the correct order, it will stay as it is, and in every step it will start from the first index and take the additional elements, right? So this is the explanation of bubble short. Let's jump into the time complexity, how much time it takes. If you don't know about what time complexity is, how is the actually space complexity, and all of these things, we'll cover it. We'll cover it in the later in this video, later in this course, or in a separate video. We'll cover it. So for now, it's to you just understand how much time you will need to run an algorithm, you can say. Basically, what is the basically efficiency, how can you detect the efficiency of the algorithms, right? There's a lots of algorithms you have, like bubble short, selection short, merge short, insertion short. So how could you decide which algorithm to choose? It is done by the like comparing the time complexities, right? So what is the time complexity of this? What is the time complexity of bubble short? So in bubble short, bubble shot, basically we took how much step we took? We took four steps. We took four steps. In each step we have one, two, three, four, and five. In each step we have five generally comparisons, five generally sub steps. And one, two, three, four, and five. In all steps we have five comparisons. So actually, what do we have? If we have the n numbers, so now we'll talk about time complexity, right? Time complexity. Type complexity. So basically, if we have n numbers, if we have n, numbers, and then we would have n minus one sub steps. We have n minus 1 substeps. So so the what the time complexity became n numbers and n minus 1 substeps. That means n minus 1 multiplied by n. N multiplied by n. So so the time complexity will become time complexity time complexity will become basically n minus 1 times n. That means n square minus n. So in the basically in the time complexity we remove the like lower basically important values or the variables the constants. So we'll remove this. This is not basically significant for us. This is not significant for us. Well, significant part for us is basically this n square. So what it will become n square. So the time complexity so the time complexity of the time complexity of the bubble shot algorithm is basically n square. Okay, so and space complexity because we didn't use any extra space like any auxiliary space, so its time complexity also became basically it should be constant time complexity just because of one. So to be the time complexity became basically space complexity became the space complexity, so it will become of 1 because we are not using any extra basically extra space, basically extra auxiliary space for storing anything. Okay, so it will be because of 1, basically constant space complexity. So now we'll see the code of the virtual algorithm. Okay, so let's get started. So let's start with the code of the bubble shot algorithm. So we are doing the code in the Replit. So Replit, if you don't know, Replit is genuinely a online website, or you can say if you can also find it in the mobile also, mobile app in the Play Store. So here you can code basically it is like in GitHub. So here you can make your REPL and you can share it with anyone. Okay, here also yeah there is many features. You have bounties where you can learn, where you can basically earn monies, and also it has a inbuilt AI feature which is called Ghostwriter. Where you can like ask any writing any codes, and it will write it. It will help you to write codes faster in a fast way. You will use AI for that. So let's go um, and code it here. Well, I am coding here because if you are watching this video and if you want to get the code, so you will get all the codes of my courses, all my videos, the upcoming videos also in here, like in the this CodaGo folder, and all the like codes of my channel will be here. So let's make a new folder which should be on shorting, create folder, and we're in the shorting folder now. Now we'll make a REPL, which is basically we are using basically Java programming language uh, for now at least. So like bubble short. Okay, so this is public for now. Okay, Java programming language, and now creating REPL. Let's create it. In time. Yeah. So yeah, uh, so this is the code actually. Main of Java and stuff. So it's code. So what we'll do, let's create. So let's get started with the code. So in here we're creating a list of numbers. We're creating a list. Suppose it'll be int error. If you don't know about Java, uh, we'll be doing it in my upcoming videos, and all the things about Java, the basic to advanced level, we'll be doing it. So don't get bit tensed here. So int it will be 3, 4, supposing any random number, 5, 5, 2, 1. Okay, and what we'll be doing. basically my PC is not a high end, so it is saying that to upgrade the resources because it is using all the resources. Yeah, it's okay. It's okay. I will be doing something for that. Okay, so let's jump into it. Become the code. So here creating an array which contains basically a list of numbers. So now let's create below code is the sorting is the bubble sort algorithm. So here we are using the for loop and I go to 0. Really, first of all I am writing the code and then I will be explaining it. Okay, so length plus plus minus 1 4 and j equal to 0. J is less than j is less than arr dot length minus 1 j plus plus. So what we'll check here. Okay, so we'll check a condition. So if arr of j is less than, so it is greater than arr of j plus 1 to adjacent elements, then we'll swipe it. So temp equal to arr of j, arr of j. This is the how swiping works. Arr of j equal to arr of j plus 1, and arr of j plus 1 is equal to 10. So that's it works. Now just printing the elements, displaying printing printing the sorted array. Plus plus. So yeah, printing it. System dot print print. Yeah. So I'm printing it arr dot arr I. Yeah. So it works. This arr is never used. Did we used it? Yeah, we used it. C plus 1. Here we used it. Yep, I think it should work. Yeah, so it is short. It is sorted, and it will be giving us 1, 2, 3, 4, 5. Right. So let's now explain how it works. How is it working actually? So the first line we have an outer loop, which is executing from I equal to 0 to arr dot length minus 1. Why didn't we arr dot length minus 1? Because in the steps, in the number of steps, basically here in the number of steps, um, we have 4 steps: step 1, step 2, step 3, and step 4. Although the number of elements we have 5. So we just reduced the arr dot length minus 1. Again, in the inner loop you have arr dot length minus 1. So why is arr dot minus 1? Because generally we are generally executing from we're just executing from this one, right? This one, first of all this one, then this one, then this one, then this one, but we never really gone to this one. I think we are really interested in the uh, first elements, like n minus 1 elements, because the last one we don't need because its next additional element is not there. So okay, so we need only n minus 1. Okay, n minus 1 in the inner loop. That's why it has Similarly, that's why it has and minus 1, the array dot length minus 1. So in the inner section we have array dot, we have a check, like here's the check, right? Left, if left is less than right, then it is okay, else swipe. So what do? We just uh, give an opposite condition like array dot j. If array dot j is greater than array dot j plus 1, that means it's the else condition, so we'll swipe it. So how is swiping it? There is the explanation. I'm doing it. Swiping, if you don't know about the swiping condition, I'm explaining it here. So swiping, how swiping works, with J is really new to programming, so it may be something that you want to know. How swiping works: suppose you have a variable a equal to 5 and b equal to suppose 3. Okay, so to swap these two values, you have a suppose you have another third variable. You need another third variable, although you can basically swap these values by some calculations also without using a third variable, but we'll be seeing in some other videos. But here we are using this third variable to swap two values because it is less confusing. So suppose we are taking a temporary variable. Okay, so yeah, we are taking a temp variable, and here we are storing the value of a. That means temp now temp is now 5, right? Again, in the a we are storing value of b. That means now a is equal to 3, and in the value of b we are storing temp. That means now b equal to 5. Here we are assigning it. So it is 5. That means first of all, in the first case a equal to 5, and after the computation a is equal to 3, and in the first case b equal to 3, and after the computation b equal to 5. That means the values of the a and b are swapped. That's what I've written here. That's what I've written in temp equal to rj. That's what I've written. It's just basically swapping the two elements, swapping the values of the two elements. So that's how it works. So it will generally uh, like short the whole thing, how I explained it here. It will just short the whole thing like that. And in this case, printing the shorted array, it's just printing it's just go traversing through the elements of the array and just printing it one by one. Man. So you can generally put any values here, like 0, 10, can give multiple tens, multiple ones also, and it will also sort the element in the same order. Okay, so uh, we'll take it to time because my PC is not so great. So this one, so yeah, it just sorted the whole thing and printing it also. So that's the whole thing. But and you can also make another thing here. You can take input the elements of the array, and you can sort those things, right? You can make it like that also, like this also, right? For that we have to import a basically package, import java dot util dot scanner, which is used to scan something or taking input, dot scanner. Okay, this is a scanner class, and we making scanner offset. Well, don't be tense, we will be basically covering these topics like what is scanner, what is class, what is offset in our upcoming videos. So don't be tense for that. Scanner, suppose we're using offset o, name is o, equal to new scanner system dot in. Okay. uh yep. Now generally we are not doing anything. We also need the size. We also need the size. Also need the size. So we have to define a size variable. We'll take the size of the array, int size equal to generally we'll taking input in size, and taking input here, so equal to 3. First of all, we are printing in message, system dot out dot print ln, and going to enter the size of the array. Like it is dynamic, okay, dynamic, a bit of dynamic. In size equal to generally o dot next in. That's how we take in integer values as input, and then we are defining an array. We are basically initializing an array, um, equal to new int, and giving up the size, right? So now system dot putting the input, input of the arrays, print ln, enter the values of the array, and we can see 4 and I equal to 0, I is less than array dot length I plus plus. We're doing it like arr I equal to new it's o dot next int, take the values, okay, and that's how it works. Length, let's run it, and it will work definitely. Let's take a lot of time. Yep, under the size of the array, suppose we're taking 5 uh, elements, so they're taking 5 elements, the values of the array, suppose 3, 8, like 1, 2, and 10, so any random values, and so it's just giving the sorted, basically arranging it in the sorted order. So this is the whole video of the bubble sort. This is the code of the bubble sort. You will get it in my Replit account. I'll be giving the link in my description of this video. And so if you want more videos like this, like it, share it, and learn in public, like in public with the hashtag, basically share it in the Twitter, LinkedIn, and with the hashtag learning with Ronak. And that's great. That's how we can contribute, to the society. If you know, if someone get help from your tweet or in the LinkedIn post, so that would be great, right? Basically you're also creating some value by your post. So that's it for today. See you in the next video. That take care of yourself. Bye bye.